Welcome to The Wonder, exploring perspectives, rituals, and observances of modern, naturalistic, earth-revering, pagan religious paths. Here are your hosts, Yucca and Mark.
Welcome back to The Wonder, Science-Based Paganism. I'm your host, Yucca.
And I'm Mark.
And today we're going to talk about wonder. So that's what we're about, right? This is The Wonder. So we're going to explore the idea of wonder. And then we're also going to talk about a few things that inspire that in us as well.
Right. Things that make us go, wow.
Yep.
Yeah. The reason that I suggested that the name of the podcast be The Wonder is that I think that is at root the spiritual motivation, right? That, yes, there's the desire for meaning, there's the desire for a sense of place in the world and purpose in life and all those kinds of things. But fundamentally, I think that sense of just being awestruck by the fact that we exist, the fact of the universe and the world existing, I just think that's really a core spiritual sentiment and or experience. And so a lot of what I focus my rituals on and, efforts at creating, materials to support other people in creating their rituals is about fostering that sense of wonder and awe.
Yes. Yeah. And there's so much of it, really. Wherever your interests lie, there's just so much to explore, and it's one of those sensations that's very hard to describe, but it's really feeding, and it's to experience that.
Yeah, I mean, the more I learn about the world, in microcosm or in macrocosm, the more often I want to say, wow, that's amazing. I think about, there's millions of examples, but toxoplasmosis. Let's start there. Okay. This is a virus that is that cats get, and it's also communicable to humans and to other mammals. Toxoplasmosis controls your brain. When it goes into rodents, they get careless. They get bolder and braver and more foolhardy. And that works perfectly for cats, right?
Yes, it works out, right?
So now cats have toxoplasmosis, right? And cats that have toxoplasmosis are friendlier. They are more apt to be domesticated. So then they move in with the humans, and the humans, by contact with the cat's feces, can get toxoplasmosis. And one of the things that it makes them really want to do is to feed the cats.
Yes.
So, literally all of this stuff is scientifically demonstrated. All of this is this little tiny virus, which is, just a little string of genetic information. And all of this stuff is true. And you look at this and just go, my God, how is this possible?
And it's all over, right? I know that that's something that is regularly tested for. If you're pregnant, they go, oh, do you have a cat? Okay, let's test you for that.
Yeah.
Yeah. And I don't know if there are what health implications there are for that, other than it does have some impact on personality.
Yeah.
For people as well, that it makes them more like that their relationship to risk is a little, just like with the mice, is a little bit different than it might be if you didn't have the infection.
Yeah. And it makes them a little bit more agreeable as well. Just a little bit more amenable to going along with whatever somebody else suggests, which is just a hell of a thing. We think we have free will. We think that we are piloting ourselves through our lives. And here comes this little bug, and it actually distorts our decision-making process.
Well, it challenges the idea of who self is.
Yeah.
There's a lot of things today that do that really have us look at what is me, really, right? What, and especially when we start getting into the realm of the microbiome, and where do we start drawing the line between my microbiome and my cells? Which ones are me, which ones aren't? Are we distinguishing between DNA? What about mitochondria? All of that stuff we're starting to find that the lines between all of that are a lot more blurry than we used to think.
Right. Each of us is a functioning interpenetrated ecosystem.
Mm-hmm.
One emergent property of which is this thing called consciousness. But that because it is an emergent property of a body, which is an interpenetrated ecosystem, is heavily influenced by what's going on in that ecosystem.
Yeah.
And some of that is human DNA and some of it's not. In fact, more of it is not than is.
Mm-hmm. So let's before we can, there's a whole bunch of different things we can discuss, but let's come back to the idea of wonder a little bit before going into some of the specifics of things that evoke that sense in us. One of the things that we were talking about when we were coming up with what topics we wanted to discuss was the idea that some people have that wonder has to also include ignorance, that you can only have wonder if you are ignorant about it. And that's something that I want to say that I don't agree with, right? I think that wonder often has humility as part of it. And that certainly for me is often a sense when I look at the night sky, I'm just overwhelmed with the awe and the wonder of all of it, and the knowledge that I know very, very little about it, but I also know a lot about it, right? That's my field. I know a lot about that little red dot right there that we call Mars, right? For me, only makes it more awe-inspiring because there's even more. The knowledge of all of that is part of that awe, but also the recognition that there is a lot that I don't know. But it doesn't have to be, awe isn't just what I don't understand, there's awe at what I do understand as well.
Right. Yeah. When we were talking about this, I was mentioning that apparently there's some academic who has written that naturalistic paganism is somehow either faulty or not real in some sense, because the awe that happens when you don't, the awe that comes from mystery is somehow has a cachet that the awe that comes from knowledge doesn't. And I really disagree, as you do, Yucca. When I'm standing on the rim of the Grand Canyon, I can be awestruck by what a gigantic big hole that is. But the fact that I know that it's billions of years of accumulated layers of sedimentary rock that I'm looking at, that just changes everything. Understanding that the slow uplift of the Kaibab Plateau allowed the Colorado River to carve that amazing, magnificent earth temple that really blows my socks off.
Yeah.
So, in the same way that I'm, filled with wonder by a beautiful rainbow, even though I understand how refraction works.
And then you get to be awed by that.
Yes.
And then thinking, and then it leads to, wait a second, our eyes perceive those particular colors. Why is that, right? And tracing all of that back, and we're back to, jellyfish. We'll come back to jellyfish in a while. Yeah.
Yeah. So, what I find is that scientists who truly embrace the scientific mindset, and there are many scientists who don't. There are many scientists who they're either ego involved with their findings, or they're just very, very narrowly focused and, are very invested in being emotionally dispassionate. But the scientists that I know that are truly filled with that humble curiosity, just to, I just want to find out, how does this work? Einstein was one, Feynman was one, Hawking was one, Carl Sagan was one. These are people that are, elated at what they know about the universe, filled to the brim with joy about what they know and about what they can observe, because they're looking with informed eyes, not just looking at something and going, wow, that's very cool and it's mysterious. I don't know what it is.
Yeah. Last episode, you'd mentioned the pale blue dot from Sagan, right? And that's one that often comes up for me thinking about with the awe, just seeing, just that one image. You can think of that particular image, which, by the way, the New Horizons, which is the craft that went to Pluto and is currently exploring the Kuiper Belt, is in its second extended mission. And one of the things that they are currently investigating whether they can do is seeing if they can turn it around and look back, because the camera that they have aboard New Horizons is, first of all, farther out, but a much more advanced camera, being something that was launched in the 2000s rather than something launched back in the 70s. And so fingers crossed that we might have another image looking back from even farther. At the moment, it's currently studying the ice giants from the other side, which we've never done before. So, but coming back to the original one, that just looking at that image, that it is something big that we're looking at, right? But we've used the examples already of thinking about awe in terms of the Grand Canyon or the night sky, but there's also awe in that tiny dot, right? It is huge because we're looking at an entire planet, but we're also just looking at what looks like just a mote of dust. And awe doesn't have a limit to size, right? Awe is not only in the giant, in the huge, awe is also in the tiny and the quiet, and it just at any angle that you're looking or listening at, there's just that. I mean, I just don't even have the words to say it because it's such an experiential thing.
Well, in the contemplation of scale itself, right? Even just contemplating the nature of scale, we know so much about the subatomic world now, right? We know quite a bit about, the realities that are happening down at the quantum level. And here we are, where microorganisms are incomprehensibly small to us. Our own cells are incomprehensibly small to us. We have dust mites living in our furniture, and we have eyelash mites living in our eyelashes.
Those delight me. I love those so much.
Yeah, me too. I think they're so cool. So, the tiny goes all the way down and the big goes all the way up. And that in and of itself is awe-inspiring, that the universe is so intricate, so amazingly finely defined, that it has all those different layers of scale, and that it has since the Big Bang. From the very beginning, from the Big Bang, we started out with little tiny protoparticles, and things have been snapping together into increasingly complex emergent phenomena ever since. If we didn't know anything about physics, if we didn't know anything about evolution, if we didn't know anything about cosmology, we couldn't appreciate any of that. And it is awesome.
Yeah.
It's just awesome.
One of my favorite things that I do with my students is I have a 4-minute video that is of the scale of the universe. And we start at a Planck length, and we go all the way up to the observable universe. And it's just, you're zooming out, right? And you're just going out, each time it's 10 times larger. And I start by asking them, okay, everybody, I want to get a vote. Do you think humans are big or humans are small? Right? Are we big? Are we huge? Or are we tiny? And get a vote from everybody, right? And mark that down. And then we watch this video, and it takes about 2 minutes to get to humans, where you can see humans going from the smallest theoretical size. And it still takes a while to get to the smallest confirmed size. But just watching their faces as we're going out and them going, wait, what? And then we start getting up into the bigger scales and the bigger scales, and we're getting all the way up to galaxies and super clusters. And then we're up to the observable universe, which probably there's way more universe, but there's a limit to how much we can see, right?
Right.
And then asking them next, okay, does anyone want to change their vote? And the quality of their voice is different after watching this video, right? And you're just seeing them for the first time go, wow, there's nothing like that. And of course, almost all of them change their vote at the end to both, right?
Yeah, exactly.
Yes, we are unbelievably huge. And then, but we are tiny.
But we're minuscule. Yeah. That's great. That's a super great lesson for science students.
Yeah. I mean, these are specifically for my science students, but I think that's a great one in any field, right? Whether somebody's going into science or not, just a perspective on the world.
Yeah, absolutely. And so, one of the things that I've said about atheopaganism is that it's the spirituality of the verifiably real. It's possible, theoretically, not consistent with any scientific theory, but conjecturally, it's possible that there are gods, right? We don't have any evidence that would lead one to conclude that, but we can imagine that might be true, right?
Sure.
Irrelevant to me.
Me too. That's the thing I was going to say. I don't really care
if there's so little evidence for it. There is so much here that I am just knocked out by, and it gives me so much of a sense of meaning and joy and appreciation that I don't need to extend to stuff that requires me to suspend my disbelief in order to embrace it. I don't need to go there.
Right. Well, why don't we talk about a few of the things that recently have given us that sense of wow. And also I want to put in an overlapping feeling as well, as that delight. Right. I think that delight and wonder aren't necessarily the same, but for me, they often come together. Right. So a couple of the ones I want to talk about are just ones that I just find delightful, as well as awe-inspiring. But do you want to start? Or
why don't you start while I'm figuring out what I'm going to do?
Sure. Well, we've been on the space one for a while. So I have some non-space stuff as well, but there's a paper that I read recently, and actually it was by the PI of the mission we just talked about, New Horizons, so Alan Stern, and he was talking about IWOWs. So IWOWs are internal water ocean worlds. So these are planets like Europa, like Pluto, and Enceladus. It turns out that oceans are really, really common in our solar system, and presumably beyond our solar system, right? And so what we are seeing is that we've probably got these worlds that have water, liquid water, inside with thick crusts of rock or ice on top. And we've never been able to go down into any of these oceans. There's not yet. I mean, maybe one day, but there's a lot of conditions in these places that we think would really be good for life. For instance, with Europa, we think that there's probably hydrothermal vents at the bottom of those oceans, that there's, that's probably salt water, organic compounds, all the things that we would need for Earth-like life.
Yeah.
And so in this particular paper, which I think is going to end up being one of those papers that people look back on, like Dyson's paper about trying to find extrasolar civilizations and things like that. But what he pointed out in this is that these IWOWs are much better places for civilizations to evolve than worlds like our own, which are EWOWs, external water ocean worlds, because worlds like Earth, we're subject to how cranky our star is being, right?
Mhm.
It depends on how close or how far away from we are from our star. Asteroid impacts, right? That's had a pretty big impact, so to say, on the ecology over the years. So civilizations, now, and again, we don't know if anybody else is out there. We suspect there's,
Mhm.
trillions upon trillions of planets. That's a lot of opportunity for there to be civilizations. But that these worlds would be more likely than EWOWs to develop civilizations. Now, if that was the case, this is the part that makes me just delighted to think about. If there are civilizations, they would be very unlikely to know that stars existed, because their world
Mhm.
would be under 60 kilometers or hundreds of kilometers of ice.
Right.
And eventually, maybe they might drill through that and go up to the surface and find out that something's there. But they wouldn't necessarily have the same drive that we've had to go explore the stars, because we see them, right? We
Mhm.
see the stars right there. Now, it's harder to get off of our planet than would be to get off of one of those planets, assuming that we're talking about IWOWs that are smaller planets, right? Like
Right.
Europa is, the gravity is much, much lower there.
Yes. But you have to get through those kilometers of ice or rock
Oh,
first.
yes. And bring all your water with you. I mean, we got to bring our air with us too. But if you're from that, you're going to have to bring your water. You're unlikely to be using the same sort of light. They probably wouldn't see with the part of the electromagnetic spectrum we do.
Mm.
Also, if they're there and they are using radio, which would be very odd for them to have figured out radio if they didn't have other type of using visible light, but that probably wouldn't leak through the ice. So we might not even know they're there. So it just delights me to think that the universe we might be the weird aliens that live on the surface of planets in the harsh light of a star, where everybody else out there is, swimming around, and, they're the octopi people,
Mhm.
right? So that delights me.
Very cool. We've talked about this before, but if you haven't, go see the movie Europa Report.
Yes.
It was made on like a shoestring budget. It was made for like $8,000 or something, some insanely low amount, and it is a fantastic science movie.
Mhm.
Really worth seeing.
Also, before we do, I just want to make a comment real quick. Some of you might have noticed my usage of the term planet. That is consistent in planetary science. We do not use the IAU's definition. That has never been actually used in any science. So referring to bodies like Europa, Pluto, Enceladus, all of that as planets is consistent with the scientific usage of the term. So just if anyone caught that, that's how we use it in the field. So
Mhm. Mhm.
yeah.
Yeah, that it is. It's awe-inspiring. The idea that these self-contained worlds could be, and of course, what that does is it begs the question, well, okay, is our universe a bubble of something that's in a matrix of something larger?
Mm-hmm.
It seems that that's the way that reality works. Could the Big Bang have been an extrusion of force space into, further dimensions that have other stuff in them that's going on?
One of my
But
personal favorites is black hole cosmology, which of
uh-huh.
course is still outside of the actual realm of science because it's not something that's falsifiable at this point, but it's a very popular idea among cosmologists, is that inside each black hole is a new universe. So the Big
Mhm.
Bang is basically a white hole from the black hole of another universe, and inside of each of our black holes is another universe that just keeps, creating more and more and more universes.
Right.
That one makes me really happy.
Yeah, and there once again you see the magic of fractals, right?
Mm-hmm.
That same repeating pattern happening over and over again, with every iteration slightly different, none of them identical, but repeating in patterns over and over and over again.
With slight difference between each universe, that actually allows for natural selection.
Yes.
Because if you have universes which are more likely to make black holes, then they're more likely to pass on their slight differences. But again, we don't know. We're just playing with ideas at this point.
Exactly.
Right. We don't have any evidence to support this, but they're fun ideas. Yeah.
And they're fun ideas that can inspire awe and wonder just through being somewhat scientifically informed, right? That's awe and wonder that you can't access if you're not somewhat scientifically informed, because you don't understand the concepts. So once again, this idea that things need to be capital M mystery in order to be awe-inspiring is just, it's just not right. I don't understand where that person's coming from at all.
Well, they do them. We'll be over here talking about wonder and new research and all that.
And having joyous and happy lives and building community and making the world a better place.
Sounds pretty good. Count me in.
sounds okay to me. That's worthy use of my time. So what was I had a couple of examples, but I'm looking out the window right now and I'm just watching tree branches blowing in wind. And understanding that there is a mathematical language that can describe that. And every one of those leaves has a friction coefficient, and it has a particular springiness of its stem and of the branch that it grows from. And the wind is turbulent and it shears through all those different surfaces, and it causes very specific kinds of motions, none of which are ever exactly the same each time, but all of which can be somewhat predicted. You can predict that it's going to go back and forth in some kind of way. And I mean, in the Einsteinian sense, that what that means is that chaos mathematics is the language of God, right? It's not in a literal deific being kind of sense, but that the universe has a mathematical language that will describe it. And that I just find stunning, just stunning. And particularly the constants, which are just weird. They're all irrational numbers, right? They're strange, but they're there.
They're beautiful, those numbers.
Yeah, they're demonstrably real. So E and pi, all of those, I, which of course is impossible, and all of these can be used to describe actual stuff happening in the universe, and it's just glorious.
It is. And we come back to that tree. This is going to come in a slightly different direction.
Oh, right.
But that tree is doing some pretty amazing things that until recently, we didn't really give credit to plants to be doing. So that tree has roots that goes down into the ground. And what it's doing up above is it's photosynthesizing, right? It's taking air. And from the air, it's taking CO2, so carbon dioxide, and it's taking water up from its roots. And then it's taking photons. It's taking light coming from our star, and it's making sugars out of that and oxygen. Now, it's not making the atom of oxygen. It's making the molecule, right? Stars make the atom, right? But it's sticking them together and make that oxygen that we're breathing. And it's going to use those sugars in its cells. But one of the things that it does with those sugars that it makes is it makes what we call exudates, basically these sticky liquids that it sends down to its roots and it releases into the soil. And it can make different kinds of exudates depending on what its, let's call them nutritional needs are. So the plant is made out of the same stuff we are. So it's a carbon-based life form. So of course it's mostly carbon and oxygen and hydrogen, but it also needs things like calcium, and it needs boron, and it needs all of these other things. And they're in the ground. They're just pieces of the earth. So the rock but the plant can't get it from the rock. But who can get it from the rock is microbes. So there are microbes that are really good at getting that, let's say calcium, getting that calcium out of the rock, and then through the food web, getting it into a form that the plant can then take up with its roots. So if the tree needs calcium, it will release the right exudates to actually breed and grow the bacteria who can get the nutrients that it needs. So plants figured out farming hundreds of millions of years before we ever existed. And one of the really cool things that just in the last few years we've been finding out about is something called rhizophagy. So the roots of plants, and we're not just talking about some special plants, we're talking about the whole kingdom here. Not only will they grow the particular populations of bacteria that they want, but they will literally take them into their roots and eat them. They take them in and literally eat bacteria. They feed on the bacteria. And some of them, they will actually like partially eat and then spit back out so that they grow again and they actually move them, right? Because that root will continue to grow. And so they'll move them several centimeters or even farther before spitting them half digested back out. They grow again. And so they're cultivating, they're ranching and farming bacteria. And so it's just that, look out your window at that tree. That's what your tree is doing right now. Not just your tree, but the grass, the flowers, the ivy growing up your wall. They're all doing that, and they're interacting on levels that we had no idea. And we are just barely beginning to learn about the incredible interactions with them.
It's pretty awesome.
Yep.
pretty awe-inspiring. It really is. And yeah, I mean, the kinds of things that we have discovered, like when I first learned about complexity science, I read this book. There's a book called Complexity by Mitchell Waldrop, and it's a popular science book. It's about creation of the Santa Fe Institute.
Yeah, I actually read that book so I'm from Santa Fe, and in high school, well, the equivalent was high school. Yeah, I did a program at the Institute, and we literally read that book. So yeah.
Well, that was my introduction to complexity science.
Oh, nice.
And I literally would, read 4 pages and then skip around the room because, this question about emergence and about, scale is so central to the entire story of the universe. It's everywhere. It's in everything. And asking those fundamental questions about, well, why? Why when you put these disparate elements together, why when you combine 2 gases does it create a liquid? What's up with that? The property of emergence itself is one of those things that just makes me awe-inspired. Why stars? Why are there these accumulations that cause transformation where suddenly you've got this gathering that gravity has been pulling together of dust and gas, and then all of a sudden at this one transformational moment, kapow, you've got a star. It's asking those kinds of cosmological questions that I just find just thrilling.
Yeah. And again, in whatever direction, right? We've been talking about our particular interests, but it's just anywhere you look.
Sure.
Any direction. Yeah.
Sure. Zombie ants that are colonized by particular molds, right?
Yeah, the cordyceps.
Yeah.
And ants, speaking of emergence, that's where a lot of the research has been done, is with ants and how the ant colonies work and how they end up with their behavior as superorganisms where it's made of lots of little individuals, and yet they have personalities. The whole colony has its own personality that grows and changes over time. which studying helps us better understand humans on that way too, because we're each individuals. But if you look at communities, and communities on different scales, but also communities on the scale of like countries, where the countries will have their personalities that they're this made up from just these smaller parts, and we're just following these, you know, simple rules that then translates into this emergent behavior. And it's fascinating, and something, again, we're just barely starting to even grasp that that's there.
Right.
So
yeah, so look around, you know, there's so much to be just wowed by, and the next step in that process, in my experience, is gratitude. I am so thrilled to be able to be taking this ride and appreciating all this incredible stuff that's happening, to be a part of this universe that's just amazing at every level, at every scale. It's doing stuff that's just like, oh my God, how is that happening?
Right. And just for the briefest, tiniest moment, we get to be a piece of the universe that gets to think about itself, that gets to see itself and experience itself as a conscious being.
Right.
But it's just a moment. It's a blink of an eye.
Yeah. What good fortune, eh?
Right?
What incredible luck. You know, when you consider the odds, the astronomical odds against any one of us, you know, particularly having arisen through collision of genetics and, you know, the experiences that happen to us through our lives. There will never be another one of you. There has never been one of you. And it's miraculous.
Yeah. And every single thing that happened before in every one of your ancestors, it had to happen exactly the way it did for you to even exist.
That's
just, there isn't a word to describe how unlikely our existence is. Right? Astronomical is not a big enough word.
No, it's not.
It's just, you know, in my house, we've been talking a lot about grandmother Luca recently, right? And how, so Luca is the last universal common ancestor, and about how life has never stopped between each of us and her, or it, or whoever they were, right? That we're going back at least 4 billion years of choices. Now, it's split off, right? There's lots of places where it stops, right?
Sure.
But in order for you to exist, it hasn't stopped that whole time.
Right.
Your
ancestors, all the way back to microbes, never died before they could reproduce. They never did. All the way back, billions of years.
That life didn't stop between you, and because you weren't magically just suddenly alive when you weren't before. You rewind to the times, all the cells that made you rewind to that back. They were a single cell inside of your mother, right? And rewind her cells back, and you keep going. That cell, that life has just been there the whole time.
That's right.
Now, it started at some point. And trying to think about that.
And we're still trying to figure out exactly how that is, although there's behavior that we can see in long chain molecules and modeling that we can see through things like the game of life, which give us some tantalizing hints about how that all could have worked. But we haven't been able to replicate it, and maybe we never will. It's entirely possible. Or maybe we will, and that will raise a whole bunch of new ethical questions for sure.
My goodness, yes. I am hoping, and also not hoping, that we get to, speaking of Europa earlier, and just saying Europa because it's the closest of them. There's a whole bunch of other ones that we could go do too, but it's a lot easier to get to Jupiter than it is to get to Saturn or Neptune, right? But, you know, I'm hoping and also not hoping that we get to, in the next couple decades, go down and take a look and see somebody else down there.
Boy,
But if we do,
it'd be pretty
wow,
amazing.
that's Pandora's box right there. But it'd be
Yeah,
incredible. So
yeah. Well, we
let's
have
see. Yeah.
kind of bombarded you with our enthusiastic wowness about the universe.
Which any of these topics could be their own podcast in themselves.
Sure.
Yeah.
They could be their own podcast series
Yeah.
in and of themselves, any of these topics, because they're gigantic topics and we're only skipping over the top high points of them. But one of the worst things I think that our mainstream culture does is discount the value of appreciating these sorts of things.
Mhm.
Oh, well, that's just a sunset. Happens every day.
But there's a limited number of sunsets that will ever happen.
That's right. And there's certainly a limited number of sunsets for us.
Yeah.
We're only going to get a certain number of them. So it might make more sense for us to go out and go, oh, how beautiful.
And you also don't know how many you get.
Yeah.
Right? Hopefully you get a lot more. Hopefully you have thousands and thousands to come. But you might just have the one, right?
That's right.
And that's another one of those just amazing things about being alive, about being, just existing at all.
About existing. Yeah.
Yeah.
Yeah. So we could go on forever.
Well, we couldn't,
well, we could go on until we died.
Yes.
But I think we should probably stop and maybe save some of that time and energy for other things.
Sounds good. Thank you so much. This was a lot of fun.
It was.
Thank you, everyone, for being here with us. So
we'll see you next week.